In this question, we have Kenny purchasing 16 petunias and 13 marigolds for $156. And the next day he's purchasing 4 petunias and 7 marigolds for $54. We want to know how much each type of flower costs. So what we're going to do is let P be the price of a petunia and M be the price of a marigold. Well, he got 16 petunias and 13 marigolds for $156, and he got 4 petunias and 7 marigolds for $54. When I look at these two equations, I see that they're lined up. I've got my P terms, my M terms, my equal signs, and my constant terms. So what I'm next going to do is try to get my coefficients of P to be the same in each of those two equations. Well, if I multiply this entire equation by 4, my P coefficients will be the same. So that's what I'm going to do. Now we're not going to pay attention to the red brackets or minus sign yet, and we're just going to say, leaving the first equation the same, then multiplying every term in the second equation by 4, we get 4p equaling 16p, 7m times 4 becomes 28m, and 54 times 4 becoming 216. Now I've got positive 16p and positive 16p. Since the signs are the same, I'm going to subtract. But I have to subtract every term, so 16p minus 16p is 0, 13m minus 28m is negative 15m, and 156 minus 216 is negative 60. Dividing both sides by negative 15 allows me to say that m equals 4. So a marigold is $4. Well, what I'm going to do now is take this value and plug it into either of these equations. So I'm going to use equation 2 because the numbers are a little smaller. So I'm going to plug m equals 4 into equation 2. So instead of 4p plus 7m equals 54, I can say 4p plus 7 times 4 equals 54, which means 4p plus 28 is 54, which means 4p is 54 minus 28, which is 26. P is 26 over 4, or in other words, 6.50. Now we're going to use the 2 decimal places here because we're talking about money. And since m was 4 and p is 6.50, we can say a petunia costs $6.50 and a marigold costs $4. For our final elimination question, we're going to look at a mixture question. Suppose that we have coffee beans from Kenya that cost $3 per kilogram and coffee beans from Ethiopia that cost $5 per kilogram. Now, accidentally some coffee from Kenya and some coffee from Ethiopia got mixed. The resulting mixture weighed 300 kilograms, but we don't know how much of each was in there, and the total cost was $3.60 per kilogram. So, somehow we mixed $3 per kilogram and $5 per kilogram to come up with $3.60 per kilogram. We want to know how much of each type of coffee was in the final mixture. Well, a lot of times when it's tough to determine the variables that you should use, it's given away by exactly what the question is asking for. Now this question is asking us how much of each type of coffee was in the final mixture. And the 2 types of coffee are Ethiopian coffee and Kenyan coffee. So our variables should, one of them represent the amount of Kenyan coffee in kilograms, and one of them should represent the amount of Ethiopian coffee in kilograms. So we're going to let K be the number of kilograms of beans from Kenya. We're going to let E be the number of kilograms of beans from Ethiopia. Now the final mixture was 300 kilograms, so K plus E is 300. The final mixture came in at $3.60 per kilogram. Now if there were 300 kilograms, the grand total of 300 kilograms times $360 per $3.60 per kilogram is $1,080. The value of the Kenyan beans was $3 times the number of kilograms, and the value of the Ethiopian beans was $5 times the number of kilograms. So we can say that 3K plus 5E equals 1,080, and we've got our 2 equations. Now you might look at that and on first glance say we should use substitution because it would be easy to isolate either the K or the E and sub it into this equation. You'd be right. But since we're doing the elimination note, we'll just use elimination. Okay? So what we're going to do is multiply every term in this first equation by 5, and we're going to leave this second equation alone, and that's going to put us in a position to eliminate the e's. If I say 5k plus 5e equals 5 times 300, and then 3k plus 5e equals 1080, I'll have the same coefficient in front of each of the e's. So that's what we do. 5k plus 5e equals 5 times 300. In other words, 5k plus 5e equals 1500. And 3k plus 5e equals 1080. 3k plus 5e equals 1080. Now ignore the red just for a moment, and we see that we have a decision to make. If we're going to eliminate the e terms, we have to decide, should we subtract or add? Well, the signs in front of the e term are the same in each equation. And that tells me that we should subtract. So we're going to subtract the entire equation from the first one. So 5k minus 3k is 2k. 5e minus 5e is 0. It's been eliminated. And 1500 minus 1080 is 420. So 2k is 420, which means k is 210. Now I can sub the value of k equaling 210 into either of the original equations. Well, one of my original equations was k plus e equals 300. So I use that. K plus e equals 300, sub in a value of 210 for k, and I get 210 plus e equals 300. So e is 300 minus 210, or e is 90. Since k was the number of kilograms of Kenyan beans, and it's 210, and e was the number of kilograms of Ethiopian beans, and it's 90, I can say that there were 200 kilograms of Ethiopian beans and 90 kilograms of Kenyan beans.